Okay, this will be quite a shortish video just on going through a couple more laws of indices that you need to be aware of. And it just says up here, be careful, okay, when you are multiplying or dividing to combine expressions with different bases. So you can see here, we've got 3 squared times by 5 squared. And in all of the previous questions, the bases have been the same for timesing or dividing. So, it would be like 3 squared times by 3 squared. But you can see here, the bases 3 and 5 are different, which means we can't go and add the powers because your bases are different. But there is a law here that we can get, okay, which is if you have an indice raised to 1 power, you're timesing it to an indice with the same power. So this time the bases are different. So the 3 and the 5 are different, but the powers are the same. Okay, hence we've got n and n, they're the same. This can be simplified, this can be written as AB, so 3 times by 5 raised to that power. And I will show you why in a second, but this is the same thing. Let's write it in red, sorry. Let's write this as, this is the same thing as writing bracket. So A in this case is equal to 3. B is 5, so we're timesing it by 5 to the power of n. N here is equal to 2. So we can see, well, 3 times 5 is 15, so 15 squared. So we are saying that this means exactly the same thing as this. And let's check it, right? Because, well, what is 3 squared? 3 squared is 9. What's 5 squared? 25. Well, what's 9 times by 25? It is equal to 225, okay? Which is exactly the same thing. 15 squared, okay, 15 squared, we know is 225. So, excellent. So just note a new law that we didn't look at GCSE, timesing with different bases but the same power. I guess we looked at it, I guess, with surds a little bit. But anyway, we can write this as this, okay? If they've got the same power, that's really important. The exponent must be the same. So it follows on that similarly, okay, and this is why I lose my working. So what no, let's leave it. If you need to make a note of this, make a note of my working. Otherwise, let's look at this one. Again, this time we're dividing where the bases are different, okay, but the exponents, the powers are the same, which means we can write it as, this one would be 6 over 3, so 6 over 3, okay, where A is 6, B is 2, and your power is 2, so to the power of 2. And 6 divided by 3 is 2, so 2 squared, which is equal to 4. Okay, and let's just double check this makes sense. 6 squared is 36, 3 squared is 9, 36 divided by 9 is of course equal to 4, which is exactly the same thing as this over here. So you can see, again, different bases, same exponents. You can write it as A over B to the power that is given. So definitely make a note of these 2 new laws because we're going to apply them in, I think, work example 2.6 and 2.7. So this one, sorry, when I typed this up on my computer, I couldn't really write it out properly. This should really be, the bracket should be written like, it should be x power of 6. I mean, it means the same thing, but just it looks a little bit weird. It should be a big bracket covering the whole thing to the power of 1 over 3. So we're using, okay, in this one, we're using this law down here, okay, which is just saying, right, this, we're putting all of this here to the power of 1 over 3. Okay, so we're kind of going in reverse this time. We're given it in this form, which means I can apply the power, which is a third, to A, which is x to the 6, and then B, which is 8. So let's go and do that. I'm applying the power to each part of the fraction. So we're doing x to the power of 6, and that's being put to the power of 1 over 3, okay? And then we are putting that over, okay, 8 to the power of 1 over 3. So all I've done there is I put the power to my numerator part, the power to my denominator part, okay? And then the top part, laws of indices, the power rule, you've got a power to another power, you are going to be timesing those together. Okay, so 6 times by a third is equal to 6 over 3, which is 2. Let's write it out in full. So we're going to get x to the power 6 times a third is equal to 6 over 3 over 8 to the third. Okay, we know that this 8 to the third is the same thing as 8 cube rooted, which we know is 2. 2 times 2 times 2 is 8. So this over 2, and of course 6 over 3 is 2, so we can simplify that to be x squared over 2, which you could write, what's the book written there? The book has kept it as that, but of course you could write that as 1 over 2 times x squared. They mean exactly the same thing. So this is how the book has written it, but you could also write it like this. Okay, so you're just applying the power, which is this, to the top part and the bottom part. And actually you've seen this at GCSE level because you would have seen it written differently. But if you saw a surd, for example, written like this, so you saw the cube root of this, okay, this is the same question, right? This means the same thing as this over here. We know from GCSE, surds, we could have written this split up as the cube root of x to the 6 over the cube root of 8, which is exactly the same thing as this, just written in terms of indices, not surds. We're going to come on to surds in the next part of the playlist. Okay, so you have seen this before. We're just looking at it in terms of indices this time. Good. Question 2.7 is to simplify this. This time, if we look at the numerator to begin with, so let's write the numerator out in full. Okay, we've got 16 a squared b to the 8, and that is all to the power of 1 over 2. Again, this time you're sort of given, we're looking at the timesing this time, you're given kind of it in this form. So you've actually got 3 parts. You've got A, B, C. A is 16, B is 8, C is B. Just think about it. You've got 16 times by A squared times by B to the power of 8. You're applying the power of a half. Okay, you're applying this power to each individual part. So we're just considering the numerator part. That's going to be 16 to the power of 1 over 2. And then timesing it by the next part. So we've done the 16, timesing it by this bit, which is A squared. And you're putting that to the power of 1 over 2. You're then timesing it by B to the 8. So B to the 8, and you're applying the power, which is equal to 1 over 2. Okay, and we know, right, laws of indices for these ones here, right, you've got the power law, so we're going to be timesing those exponents together, okay, and then overall, we're going to be getting, well, 16 to the half. This means the square root of 16, which we know is plus or minus 4, but they just want you to write it as 4 for this, so it's going to be 4, timesing it by 2 times by a half is just 1, so 4 times by a to the power of 1, same thing, times by 8 times by a half is equal to 8 over 2, which is 4, so timesing it by b to the power of 4, and of course we can simplify that as writing it as 4, a b to the 4. So this is the top part, okay, the top part is this, okay, so we've got 4ab to the 4, but we are dividing it by ab cubed, okay, ab cubed. Laws of indices again, right, what's going to happen here? Well, the a's will cancel because we've got a divided by a, they're going to go. And then we've got just 4 on there. We've then got b to the 4 divided by b cubed, take away the powers, same base, 4 take away 3 is 1, so just 4b. And that is your answer for this one. Okay, so just being aware, right, if you've got something raised to a power, you apply it to each part, so the 16, each term, the 16, the a squared, and the b to the 8, as we saw here. Okay, and we went through it. Okay, next video, we are ready to go through the green questions, or just the textbook questions. Thank you.